Okay, ready?
Let's go.
Okay. So welcome to today's AllTalk for October month. Today we're going to talk about Amazon Rekognition. And let's start by diving into the... Un momento. Bueno, siendo fit. Okay. Okay, so let's start by talking about the definition of about what is Amazon Rekognition. Amazon Rekognition is a deep learning-based image service that allows us to search, verify, and organize millions of images, and also allows us to have some very impressive features like object and scene detection, facial analysis, face comparison of several pictures of images that can be even in batches, and facial recognition. This can be also not only in pictures, but as well in video and in live streams as well. So let's start by watching an example of the facial analysis feature. Here we can observe a complete analysis of facial attributes for the person in this image. And also is showing a confidence score, which basically what says is the how much can be sure about this feature here, about the list that we have in the right panel. For example, we can see that we have, for the first one, that looks like a face with a 99.8% of the level of confidence. She appears to be a female with 100% of level of confidence. And once it's going like more specific into these features, for example, he appears to be happy, shows only 93.2%, because it's not like super exact, but it's pretty close to what is showing actually in text. For example, we have wearing eyeglasses, which is different, a little bit different than showing that wearing sunglasses. Also, for the facial analysis, we have that it shows facial landmarks such as the position of eyes or detected emotions. It can be happiness, sadness, or anything else. For this example, we show that in this picture, it's showing that we have a female. Her eyes are wide open. She seems to be happy and smiling, but we can see the decrease as well in the percentage of confidence for this case. Also, this feature works for video analysis, and where you can track when a face is detected in the length of the video. So let's see, for example, now the face comparison feature. We can compare faces to see how closely they match based on similarity percentages. Basically, we have two panels. We can upload a batch of images in the left one and another different batch of images in the right one, and it's going to show a panel with the comparison. Here we can see that for the girl in the right panel, shows a level of confidence of 98%, because it shows that's pretty similar to the girl in the left of the other image. But you can see that it's very accurate as well for similarity with other persons in the other picture. And it shows 0% in this case. Okay, some cool stuff that we have about our Amazon Rekognition is the simple integration in your applications with the Amazon's APIs, which are tailored to your programming language or platform. There's APIs for JavaScript, Java, Ruby, Python, Node.js, among others. There's a lot of documentation in the website. As well as some very nice examples that you can run using the SDK. It has a very low cost for a number of images or minutes of video, and the face data that you're storing, typically on the S3 buckets for recognition. There are no minimum fees or upfront commitments. For the pricing, we have that is as low as 10 cents per 1 minute of archive video analyzed. When we analyze only less than 1 minute, for example, it's going to have a pro rate of the partial minutes analyzed. And you can also do live stream, and the price is as low as 12 cents per every minute of live stream that is being analyzed. Also per rate for partial minute. In the cases of images, we have that the price per 1,000 face metadata stored per month is only 1 cent. The storage charges are applied monthly and also per rate for partial months. And there's a free tier that allows us to recognize up to 5,000 images per month and store up to 1,000 face metadata. For the first 12 months, and 1,000 minutes of video per month for the first year. Okay, let's see now a different utility, which is the image moderation utility. Rekognition also can identify images that contain suggestive or explicit content that may not be appropriate for your site. Some usages are to improve photo sharing sites, a kind of Shutterstock sites, forums as well, dating apps or content platforms for children, or e-commerce platforms, and much more. So, an example here, which is the demo for the feature in the website, we have that is showing for an image that has a female swimwear or underwear in the picture of the right, and it shows accurately that we have some suggestive or adult content in there with an 83.5% of the level of confidence in that case. This is going to allows us to use in our algorithms in order to see which is the content that we actually want to show and which is the one that we want to filter. So how the image moderation thing works? So basically, any user can upload an image of photos through his mobile device or as well through the computer, and it's going to be loaded to an Amazon S3 bucket. Then using the Lambda function, the Lambda function is going to be triggered, and it's going to call the Rekognition service. Rekognition service is going to detect explicit or suggestive content in the images, and it's going to return the confidence score. That is the one that we're going to use actually in our algorithm, and we're going to moderate, and the images allowed or rejected are based on the confidence score. And finally, we have the output. The rejected images can trigger a notification, and approved images are going to be shown to the users. Okay, so now let's run some practical examples on the website. Okay, so let's try and upload a different image than the ones that are on the website. So that I'm gonna upload an image for a Google Office. In this case, that shows us that it has many things in the room. For example, we can watch there's a bicycle, and it's showing, it's the object that is most in the front, and actually showing a 99% of the level of confidence. It's detecting many other objects around the picture. It's going as well into more general topics, like a bicycle or a bike. It's a vehicle for transportation. It seems to be an apartment or a building. We click on show more. We're going to watch even more specific stuff. Like we are indoors, or even tries to go deeper into trying to figure out that it is a Vespa in there, but only showing a 55% of in the level of percentage, and many other features or aspects in the picture that can be correct or wrong. For example, in the end, it's showing that we have a child or a human or a person, and if we look further into the image, there's no child, there's no any person. anywhere. So nowhere. And I think it's because it's probably trying to match some object that is very far away in the picture. So it's not 100% perfect, but it's quite accurate, as we can see. Let's try the facial analysis. For example, let's go and upload an image for a very known person. In this case, we're gonna use a picture of Lionel Messi. And it's also showing some very accurate features. In this case, very general stuff, like it looks like a face. He appears to be a male and seems to be smiling. And interesting thing is the age range. It's quite accurate as well. It's showing that 29 to 45 years. It's a bit wide, but I think it's there, yeah. He's not wearing glasses. Mouth is closed. Has a bird. Very nice stuff. I don't know if it shows it. If it has a tattoo or something like that, it would be cool. No, that's the subset that is showing for this case.
But it doesn't know that it's Messi.
Because this is not the feature. This is only for the facial analysis.
Yeah.
But there's another feature, which is the celebrity recognition. And in this case, well, he's doing a really nice marketing of his own product, of course. I'm gonna put myself in here. Jeff Bezos. Also for this guy here, which is the CEO of Amazon Web Services, Andy Jassy. Match confidence of 100%. So let's try with Messi again here. But we're gonna try with a picture with lower resolution to see what's gonna happen. I mean, Messi should be recognized because everyone knows Messi, right? So let's see what happened. The results, okay, no celebrity faces recognized. So I think in this case, I don't know if it's the image resolution or what, but somehow when I try to upload something lower, I don't know, than 100 per 512, something like that, it's not showing like the most accurate results. But and again, if we come and upload the other picture, it actually works. But only with a match confidence of 68% below of confidence. Okay, so let's try the face comparison with the same pictures now. I'm gonna upload here the first picture of Messi. And, well, of course, he's not similar to any of those girls. But let's try and upload another picture of Messi, and let's see what happens. And it's taking a lot of time to analyze. Seems to be hard.
Always picking more than one face.
Yeah.
Is that a no face? Third one?
The third one.
Yeah, it looks like a no face.
Here. Yeah, but it's not showing the level of confidence. It's like comparing stuff, but it's not detecting in this case. We upload again and give it a second chance. Analyzing. Okay, so there we go. The similarity of 87% in this case, very accurate, I would say. But sometimes we have this kind of thing, you know, sometimes it works and sometimes it doesn't. We need to re-upload things. So it's a tool that is in development, but it's quite nice. Okay, let's try another example now, but for text detection in image. In the demo, well, we can see that it's taking this phrase correctly. It's Monday, but keep smiling. And let's try, for example, this one. It should recognize the license plate, and it's doing it correctly. We can see in the result. And let's gonna try and upload custom image or something that we have downloaded from the web. I'm gonna try and upload this Avengers image and see what happens. Okay, so in this case, recognize almost everything. Marvel Studios phrase. Huh? Ah, of course. Yeah, basically shows bounding
the relevant
on
stuff.
the box. Ah, you want to see the relevance? It's a level of confidence here, for example. Yeah, but it's not yeah, it's not detecting. For example, this weird A here has some weird styling, but for the rest of the text is very accurate. 99% of confidence, 98%. And it's giving us the bounding box, the polygon, to see exactly where it's located in the picture. So quite nice. Yeah, exactly. Yeah, because of the styling.
Yeah.
Okay, so let's go back.
So you have a user, you don't have to teach any bot to recognize like Watson that you can.
Yeah, you can actually. You can actually. I'm gonna show a nice video right now. It's quite interesting stuff. Second. Okay. I can hear.
Tens of millions of photos. It's also available to anyone in specific regions and costs as
Going back again.
little as 10 cents per 1 minute of video analyzed. That accessibility has attracted some interesting clients. Of mass surveillance is upon us. Insanely cheap tools with the power to track individuals are now available for anyone to use, as exemplified by Amazon, which has built some cheap and accessible facial recognition technology. The tool, known as Rekognition, can recognize up to 100 people in a single image and is capable of quickly finding faces in databases containing tens of millions of photos. It's also available to anyone in specific regions and costs as little as 10 cents per 1 minute of video analyzed. That accessibility has attracted some interesting clients. According to a 6-month investigation by the ACLU, Rekognition has been put to use in a number of agencies across America, including the Police Department for Orlando, Florida, and the Washington County Sheriff's Office in Oregon. We wanted to see how easy it was to set up our own facial recognition system, so Forbes decided to try out the service. We discovered it took just a few hours, some loose change, and just a little technical knowledge to establish a super accurate facial recognition operation. To get things started, we enlisted the help of developer and researcher Matt Svensson. He set up a database into which we poured a mix of stock photos and Forbes staff mugshots. Our video teams in Jersey City and London then took some simple footage mimicking CCTV, and we ran that through the software. In every case where a Forbes employee was included in the database and the filming, a successful match was made, as shown by the little red squares drawn around their faces. Admittedly, Svensson gave us a 6-step guide, which made it much easier, but just like a recipe, they're easy for anybody to follow. There are obvious privacy and security concerns around making this kind of technology widely available. Aside from the issue of the government and police forces having cheap and quick access to a powerful system that can detect and track targets in real time, anyone with a motive and a social media image scraping tool can do exactly the same.
So I think that answers a little bit your question. it's possible to feed these algorithms with your own data, and you can create your own tools as well to create some quite interesting applications that you can use in your nowadays, and that have most of these impressive features that we have today. Okay. So for the last, I'm gonna leave this quote here, Edward Snowden. This actually, I was watching the news for these Amazon recognition tools in these days. I saw something quite funny. Actually, there's some people that was using ACLU, this tool of Amazon face recognition, and actually the tool falsely matched 28 members of the Congress with mugshots. So, yeah, exactly. So these kind of things can happen, and that's why actually we have a lot of responsibility using these tools. Actually, Amazon responded to this accusation and saying that for tools of this, this kind of tools that are so invasive and so of general use, actually you should use a high level of confidence. But I think the algorithms are right now like in development; they're constantly being tested and improving. So it's very important to have this huge level of responsibility when we're using things like that gives us a lot of power. So, well, that's it. If you have any questions right now, you can just shoot.
What do you use recognition?
For what? Okay.
As a personal.
For me.
Yeah.
Okay. I don't know. For example, I had that exactly that example. In the office, for example, if you need security, and if you need to know, or even in your houses, I think it's a little bit creepy. I wouldn't do that, but there's people that likes this level of security in your house or in your place, and you can actually detect who is walking around, or you can leave it, for example, on. But now you can put a camera, and actually this system is going to give you information that you need, and it can send you a notification. It's in the case that it's detecting someone that's entering to your home or something like that. I think it would be very interesting for that.
For like a missing person?
As well, exactly. For a schedule.
You can use the image recognition to generate tags for a bank of images, where you put in the search bar like people are smiling, and you can, let's say, send all your images to the Amazon Web Services recognition, and then to generate the follow-up list of tags, and it will be faster than creating the code by yourself.
Is it working? Video?
Yeah, I didn't test it, but I think it says that it works for video analysis per minute. The charge is per minute, and also for live stream. So I didn't test. I don't know how it works, but I think it's very similar. Should be the same, just for I don't know how many frames you can have in 1 minute, something like that. Okay, well, yeah, that's it.
Thank you. That was very good.
Thank you. Yeah. Okay,
So now for just $10 a
share.
month, we can conquer the world. Way.
We can actually.
Yeah.
What I say is, imagine this technology 10 years